Hello and welcome back to a new video in Boundless 2D, the game engine series here on the Lötwig Fusel channel. Now with this video we're gonna go into system initialization, or first video of episode 3. So we are finally there. We are talking about how our engine systems are initialized. This is very important because, well, I do want to make a distinction. I'm doing a lot of infrastructure stuff before we are actually getting something done because of a very important thing. I don't want to have anything limiting the engine at the end. I don't want to have problems with proper multi-threading in the future. I don't want to have problems with inversion of control and injecting code, new features into the engine later. And I don't want to have issues of being limited by just one instance of a game running. I want to have an editor. I want to have a game. I maybe want to have 2 games. I want to have 5 games running in one editor to copy and paste stuff between them. I want to have like everything that you can imagine, every fancy feature that you can think of. I want to have all of that inside of the engine, and I want to not implement it, but I want to have the possibility to do so. And I also want to have the possibility so that you can go in, fork the repository, write your own engine modules, use inversion of control to inject your own changes into the application and make things a lot more flexible. This is why I'm doing that. This is why I'm writing stuff like that. And this is important why we need to talk about system initialization now. So let's actually take a look on what system initialization actually means. Now, first of all, I want to make an important distinction between the application and the instance. This is a concept that you need to get used to. The same with like IOC registrations, IOC stacks, and in the future also IOC applications. To be aware of what's actually going on there. So we make a distinction between an application and an instance. In this case, an instance of an engine, /game, /editor. Now, after that, I want to talk about the IOC stacks based on the concept of application instance that we have just defined. And then I also want to show an example how this could work by showing image loading, which actually nearly got me there as well, because I still need to think in the concepts of the engine. I nearly made a big mistake there, but I'm gonna explain to you what I did there and why it's wrong and why I'm even telling you that, because it's important and it is a bit more complex architecture that we're gonna build. But this architecture is gonna pay off at the end, because at the end I want to have a system that's flexible, that's expressive, that's easy to use, that's easy to implement in C++ as well as in like scripting. Now, after that, I want to quickly talk about how an application is built up. Okay, so let's start between application and instance. Now, what is an application? What is an instance? Let's start with the default definition that we have on an application and on an instance. Well, an application is basically a executable that can be run. Now, an application can be a console application, which is basically just used in a command line, or it could be a Windows form application written in C#. It's also an application, right? You double-click it, you get like a form that opens up. You can have a GUI in there and put all the data in there, click save. Like everything that's really running that you can double click on your desktop is an application. It's all a app. Every game is a application. Now, what is a instance? Well, instances have multiple definitions. Most of the time, if you want to just have a very basic thing, an instance is a instantiation of a certain thing, right? If you have like a blueprint and you're copying it, it's kind of like an instantiation of the blueprint. If you have an application and you start it, you have an instance running of the application. If you start another application, it's also having an open instance. The application is kind of like the baseline, and the instance is the concrete implementation that's kind of like running. Now, in our case, I want to a bit redefine what an application and instance is. Well, on our case, the application is going to be the process that is running, the application that has been opened. The instance, what for Windows is an instance of the application, this will be our application baseline, because instances, applications, and all of the scope, these really depend on the point of view, right? What is an application? What is an instance? It always depends on the point of view. For Windows, if you're starting an application, an instance is every open thing. From the application itself, the application is its base systems, and the instances might be internal states, right? It always depends on how you see it. Windows sees our application as a binary file, and our instance as the running process. Our application itself sees its process as the application and instances of the objects that are living in it. This is kind of like the thing that you need to wrap your head around of that. We always need to talk about point of view. And our point of view is going to be like that. The application is the running process. If you double click on the exe, the application lives. We have an application that needs to do initialization, IRC registrations, modules registrations, all of that stuff that we talked about and will talk in the future. All of this needs to be done on a application base, some basic system initializations. And then we're going to have instances. These are not going to be instances of the applications because I don't want to confuse you. We're going to need later on find a proper name for that, but currently I'm just going to call it instance. We have the application with all of its default initialization that only are allowed to run once done, like maybe an abstraction over memory management, co-initialize, Windows DPI settings, registering window classes, all of that very basic things that need to run are on the application. And then what we're going to have is instances. Engine instances. We're probably going to call it engine instances. And the engine instances are kind of like instances of systems that can run independently in one application. For example, a renderer, a configuration system, connection to online services. All of these things that can run simultaneously without interfering each other in one application are going to be in an instance. It's really important to have them all in instances to make your system as good as possible and as flexible as possible, because we in the future might want to run multiple instances of our game, different games, different applications in one, not applications, but different subsystems in one running application. For example, the editor. The game editor is the best example. The game editor has its viewport, has its development views, has its UI. It is one instance of the application. We have the application, and there's one instance running. This one single instance is basically, for example, the editor. And then on the editor, you click play in editor, and then the game starts. A game state is copied, the game starts running, there's maybe native code that runs, there's scripting code of the game that runs, and this is a whole different instance, an isolated instance from the editor that's still hosted in the same application. And this is the concept that I want to have, application instance. To talk a bit about this a bit further, we have the application with platform initialization. Already talked about this co-initialize, Windows DPI, window class, the stuff that needs to happen on Windows. Might be also things like managing threads, like a thread pool, like fibers, conversion functions between threads and fibers, thread local storage, fiber local storage, all of these Windows-specific stuff. Platform initialization, set this all up, register all of the indices that are required for fibers and threads, everything in platform initialization on Windows. Then we are getting to like engine stuff. Like we have the engine initializations, like logging systems. How does the user wants to have the logging? For the editor, we're just going to log it to a certain virtual console and to a file. If we are under runtime, it's configured differently, so we basically log it to just the file system, for example, but in a different way. And all of these like kind of like specific things that need to be done on the engine side. Things that don't really depend on Windows, right? Or Linux, or whatever platform we are, like something that has been abstracted away by modules, by libraries. All of that happens in the engine side, but still things that are like independent on how many instances we are running, right? We still want to have our game logs in the editor. This is why logging and things like that are like on the application base and not on the instance base, because we have the logging system on the application and the editor is just interacting with it. The editor spills its logs to the logging system, the game spills its logs to the logging system, and the editor might have a callback that actually gets all of these log messages back to display them in a console. That's the whole idea of the system, so that we have it together but abstracted. And engine-based logging, job systems, GPU subsystems, all of the things that are kind of like set it up and just required once, right? You don't need two debug layers or DirectX 12. No, there's only one. You don't need two job systems that do scheduling and thread local storage and things like that. No, you want to have one job system that you can overview in the editor, which you can actually maybe nicely see. All right, these are the tasks that are currently executed by the editor. These are the tasks that are executed by the game. If I have two game instances running, that might even communicate between each other, because like stuff co-op or things like that, you might basically see then, all right, this game has the following tasks, the other game has the following tasks running, and all of the things, like they are torn apart by the instances, but they are together in the application, like subsystems, job systems, all of the things that is common and then used is on the application in the engine base. Now, talking about instances, what actually happens when you're starting a game, right? And you want to, of course, have systems on a per game base, right? The renderer with the graphic settings, everything, the configuration, the actual online services that communicate to different game instances or a dedicated server. All of these things shall run as a single instance. Talking of game server, it's also a different thing, right? You can have like an application that actually hosts the game server in the same application, right? Because we don't have dedicated servers or we are on a development build, we want to have the game server in the application. So we have one instance of the game server and one instance of the engine, and the online services are basically then different implementations that just talk to each other or talk to the network. And we are really, really flexible here and can do whatever we want. We can have like a virtual online services, VOS. It looks like a normal online play via Steam, but it's going through our development systems. We want to have all of this stuff on a per instance base configurable so that we can have like a development instance, a development server, and all of that stuff hosted in one instance, and of course all controlled by the editor, because the editor is our powerful tool that the developers use, right? We have the 3 instances running. A game, maybe even 2 games to debug stuff, 2 games running, a server running, an editor running, multiple instances that all communicate via the application but have their own dedicated systems for like rendering, online services, config, and all of that stuff, so that it's all together but apart. Now, of course, building on top of the engine is the game, the thing that we actually want to create, which is like most of the time just our native code and our level loading stuff, low-level bootstrapping stuff. In general, like I want to have the game as minimal as possible, but as extensible as possible. The game in general should be just like one single file that basically just says, hey, load this default level, load this configuration, and go. And then everything else shall be done via scripting. But of course, you want to maybe do some native stuff. So all native code shall go into the game, and you are good. And then you can, of course, host multiple instances of a game. Why not? Why should you not be able to do it? And yeah, this is kind of like the idea. Or there might actually be one thing why you not be able to do that. But I hope that we can abstract this away. Yeah, we can abstract this away. To have like, then you need 2 files per game, but this is not the point, right? Yeah, I want to abstract everything away in these 4 layers. These are the 4 layers that we're going to take care of from now to the end of this video series in general. Platform, engine, game. Application, instance-based. That's it. And that's the golden standard. Now I want to give you an overview how this works together with the IOC system. Now our IOC system in version of control is actually quite simple, and we abstract everything away into registration and stacks. A registration is basically just a blueprint of how a certain object is constructed, and a stack is actually the place where the objects live. Now, what I want to have is I want to have 2 IOC stacks. Why do I want to have 2 stacks? One on a per application base and one on a per instance base. Why do I want to have this separated? Well, because the application, of course, needs to manage its own memory. If an instance is destroyed or recreated, it shall not influence the actual application. Right? The instances may have references to the application, but the application should, hopefully, or best of the best practice, not have direct references to the instances. There might be some intermediate engine systems that do like the engine part intercommunications, and that needs to be kind of like a border. Well, I don't want to have it. Level 0 stack for the application and level 1 stack for the instance. Application, like the Windows subsystems, engine-based systems, all of that stuff that's always there, and then the instances that construct their own data. Nice thing of that is, if the game like fails or encounters an error, you can just deconstruct the game and reconstruct it again. Or for example, in editor, if there is like a fatal exception that completely rips the game apart if you're playing like in editor, this can be catched, at least if DirectX 12 is not completely destroying its internal states if it happens during rendering. But if something in the game goes wrong, well, the editor will not crash because it's only going to happen inside of the kind of like the L1 scope. And since it only happened in the L1 scope, the L0 scope should be ideally completely functional. And of course, all other instances that are running next to the faulty instances should also be still up and running. And this is the whole idea of that system, to separate it, also make it more flexible, make it more reliable, more debuggable, and everything. Like, just way better. And always, of course, the game and engine and platform are, of course, going to be referencing that stack. Which doesn't mean that you are not being able to access L1 stuff, L0 stuff from L1. This can work, right? The game can request the interface that's living in L0. And that's the whole point, right? If you're requesting something, all requests go first to L0. And if L0 can't fulfill the request, it will be sent to L1. If L1 can't fulfill the request, it gets created. That's the whole idea behind the systems. That's basically the idea. We might need to rework how our IOC stuff works, but hopefully it already works fine. I don't know how I implemented that, but I think we might need to change a few lines of code that it really works at the end, but this is what we're doing, Agile Software Development. Right, okay. Now, I'm just trying to cover up my things that I might have not thought through when I implemented IOC. I mean, I thought many things through, but sometimes you need to change your things, but that's how it is. That's the idea. 2 stacks that live independently, one per instance and one per application, which should bring up stability, which make everything should be great, right? If we are then also separating memory management between these two, which we currently don't, things might be even better, because we could even react to like memory segmentation faults and access violations and stuff and just panic destruct L1 if it happens at L1. But this is probably something that we're gonna do like on a per fiber or thread base, and then on a per thread base kind of like detect which fiber it is and do magic stuff that makes applications quite heavy duty. I don't think that we would need this for engine, but if it comes for free, why not use it? Okay, so these are the IOC stacks and how they are gonna work together with the concept here that we had. Let's now take a look at an example image loading that nearly tricked me. Now, the idea here is to allow the configuration of custom image loading and to abstract away the actual physical image loading. How would this work? Well, we would define a interface. This is everything. Everything is revolving around interfaces in a version of control, or at least on a version of control, and how I do it and how I want to abstract away platforms. Now, basically, what we're going to have is we're going to have a class, an interface image codec. This is basically a codec set that is possible to decode one or many image formats. Now, an image codec could have 2 functions, right? It could have a function supports that checks for a file extension if it can support decoding from that file extension, or mimitype, or however you want to do that at the end. And then we can, of course, need to be able to decode something. So we need to be able to get an image decoder from the image codec itself. So the codec has multiple decoders in it, and we are getting the decoder by supplying a extension that we actually want to kind of like decode, and then we can get the proper decoder. Now, this is kind of like the general idea on how we can do architecture around it. What do we need in the actual game or in the actual engine part that is like using the image codec? Well, we just need the 2 functions here. We don't need multiple implementations. We just need one that can decode everything. Of course, this is never possible, especially if you're having multiple systems. For example, what could be potential implementations? There could be the Windows image codec implementation, the WIG image codec. There could be a STB, the STB image codec that is doing it with STBI or STB image, however you want to call it. WIG, of course, only works in Windows. STB works everywhere. How do we solve that problem? Well, with our module system, we're going to write 2 modules. One module is the WIG imaging, and one is the STB imaging. Now, how do we do that? Well, the WIG registers its image codec on the token WIG. The STB image codec is registering itself on the codec STB. When is that going to happen? It's going to happen when the application initializes in the layer 0. So in layer 0, this is going to be instantiated, set it up. And how is this going to be set it up? Well, it's going to be set it up on a special way. This is something that I still need to kind of like refigure out. We need to bit adapt our module system so that the actual loading works. But this is why we are here. We're going to need to actually have code that initializes the applications. Not the applications, the modules. They basically call the modules and say, hey module, I'm now on initialization stage of the application. Hey module, now I'm in initialization stage of a instance, and then the module shall have the opportunity to instantiate on the appropriate stacks. That's the idea, that this all works together. In this case, the modules would kind of like instantiate their singletons on the L0 initialization. Of course, the WIG will only be there if there is Windows. The STB will always be there. So what they are kind of like instantiated on L0, they kind of like have an instance living. Now, of course, we need to interface them. Of course, we can go into the game and kind of like interface it and say, hey, I want to talk to Vic. Hey, I want to talk to SCB. But this is not how this should work. So what we would do is we would register something on L1 base. Now, depending on the actual game, we would register something on an empty token, and we would register, or not register, but instantiate the proxy codec. The proxy codec would be a codec that is platform independent, reads game configuration, and reads the game's preferences. What is the preference list? The game could specify it wants to use WIC, STB, and I don't give a shit, for example. And then what the proxy codec shall do is it shall initialize the string WIC semicolon STB semicolon I don't give a whatever. And then it kind of like asks, okay, do I have WIC available? Yes, put it on the list. Do I have STB available? Yes, put it on the list. Do I have, I don't care, a whatever? No, I don't have it available. I don't put it on the list. I ignore it and log an info message or a warning and say, hey, the I don't whatever is not available in the current configuration. And then we kind of like have a list of codecs that are supported. And then the proxy codec can go in as soon as the request gets to it, like get decoder. And then it kind of like first asks, hey, WIC, do you know that extension? Because WIC was first in the preference list. WIC says, no, I don't know it. Then it goes to STB. STB says, I know it. And then the decoder is supplied by STB. The idea is that we have a uniform configuration, right? You have a configuration with your game that is targeting for Windows. So the configuration is WIC semicolon STB. And on Linux, it will never find WIC. So it will only ask STB. And on Windows, it will, of course, always find WIC. So it will always ask WIC first to get like the image decoder. Of course, this architecture is complex, but it's also very extensible. You could register as many L0 providers as you want. You could, for example, register libpng, libjpeg, and put them in the configuration first, and then everything is done through the native libraries, because I think that they are actually fastest. I'm not quite sure. I don't know speed comparisons of image decoding, but I would probably bet that libpng and libjpeg are fast. WIC is fast as well, but not as fast as the native library because there's abstraction going on, but I'm not 100% sure of that. And SCB is like the slowest. I know that because I have used SCB and it was painfully slow. But it's, of course, very portable. I mean, you could get away with that, right? If a game is slow on loading on Linux, then it is like that. On Windows, it's fast because it's optimized, but at least it runs on Linux, right? And then we can like have custom implementations for JPEG and PNG that are always fast and always preferred. Like you could define like a list like libpng, libjpeg, WIC, STB, and then like the matching one is gonna jump in and proceed the request, all done by the proxy codec that should also do fancy caching and stuff. But I don't want to do too much details on how image loading works because this is probably gonna be its own series. Episode. Not serious. Episode, of course. But this is kind of like the idea that's behind it, to abstract away everything. Is it over-engineered? Yes. Might it prove worth? I think it does. Why am I doing that? I'm always doing stuff that other people don't. Is it going to be too slow for a game engine? Could be, but I don't think so. Because I think I already said this in the IOC video. Everything is complex with inversion of control. Stuff will be more complicated, but stuff shall be complicated during initialization. The IOC shall only be done and run once. This is my goal for the whole series, to optimize the speed. This shall only done once. So we might deconstruct all of these WIC, SCB and stuff. We might do all construct the decoders there that are possible, or construct them on demand. But at the end, calls shall be simple. Like the proxy codec at the end is going to have a list of pointers of actual decoders and is no longer asking the further codecs because it caches them. And even further on, the actual engine systems that are using or requiring image loading will never ask the IOC stack for the proxy codec. They are always going to store the pointer to the instance. And then what this really boils down is one lookup in a hash map and one pointer call. So basically pointer call to the proxy, lookup in the hash map, pointer call. And then even like this pointer can be stored and later on even just used as a pointer call and further on requests. This is the idea. We are building a construct that is just there to make flexible initializations, and that's important. We need to always have this in mind to not get limited by the system. Is it a bad idea? Is it a good idea? Currently, I think it's a good idea. But I've never used it in production. But that's the whole point of why I'm doing this series, right? Coming up with software architecture and playing around. Now, if you're watching this video series and say you want to learn how it's done, go to somebody that has actually worked in the game industry. I have not worked in it, but I have consumed many resources. All right, so now let's talk about how an actual application shall work in the end. Well, we can write applications based on a class. Cross-platform configuration and entry point. I don't want to care if the underlying entry point is a main, a win main, a W main, a whatever main, a POSIX, fancy, PlayStation, whatever main, a Xbox managed main. No, there is no such thing. If you're on proper Xbox, you also have a main, but that's a different story. Like, all of the things shall be abstracted away. We want to have a uniform entry point. I also want to have automatic module loading. I want to have automatic loading of all of the modules that are available. I want to have automatic log initialization. This is going to be done through the modules. This is something that's going to probably be abstracted even further from our initialization stuff, but I want to have like automatic module initialization would be better. And then what I want to do also want to have is uniform error reporting. Now, why do I want to have that one? That's a special one. In an application, I want to have error reporting without fancy IOC. Why? Because IOC can fail. IOC can go wrong. There can be something going wrong in the module registration, instantiation, the iFancy logging interface, the iFancy error reporting interface might fail. This is why I want to have a dedicated uniform error reporting. Like CLE, CLI base, like fatal error during initialization. Here is no fancy SPD log, here is no fancy whatever. It just failed. Or on Windows message box. Boom. Something went wrong. That's the idea here. Uniform error reporting. Not logging, not fancy, just a bare minimum fault. And basically what I'm talking here about is an exception travels to the main. More or less. Right, this is the idea. Now what I want to also have is I want to have the layer 0 IOC stack initialization. The layer 0 IOC stack shall be completely managed by the application's base class. How is it going to be called? It's going to be a single target base class called IOC application. I am actually intrigued to put this all in the IOC package. Not sure if I want to do it, though. Even though I need to be sure because I'm going to do it in this video. No, I'm not going to do this. Well, we're already talking quite long. I need to think about it. If I want to have it really as in the IOC things. But I actually think we can. Because we can abstract everything away. We can abstract everything further down. Away from the engine into IOC. Bootstrapping is a different thing. Actually running an IOC application. But the base class is gonna probably be in the IOC package. So it's kind of like it's a part of inversion of control. I don't know. Maybe it is. Maybe it's not. And basically what shall happen is that the IOC application can be executed. And it's going to get command line arguments that, of course, also needs to be fancy abstracted away because Windows does different things than Linux. And that's bad. But we need to abstract away. Why not make it an interface? All right, then. That's it. I think. Yes, that's it. Okay, yeah, so thank you for watching. I hope I was able to tell you how I would like to have this all working. I hope I could convince you of the benefits of that system. And it's gonna work great in the end. Promise you. So, thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.